So, since there are not a lot of resources that try to help to explain or solve the English version of the math section of the Qudurat test or the general aptitude test, I'll try to help the community out. Now, this is Model 8 in the GAT book found in Jarir. I'll be trying to show some solving methods to 10 questions in Model 8. So let's begin. First of all, we have the root 25 plus root 44. Now, most root questions, when a root is being added, there's a rule about how you can simply separate those two roots in order to have two separate roots. And the way to know this, to know these is not, you can just memorize the famous square roots, or you can just divide, honestly, but it will just be really helpful if you just memorize the famous square root. The square root of 25, or the two numbers multiplied by each other that give you 25 is 5. And they have to be the same number, so that's why it's n and n. And for 144, well, the two numbers that multiply each other to give 144, they are 12. Same number as well. And then you can just solve. So you can just erase all of this and add those two together. It's as simple as that. 5 plus 12 is equals to 17, and that will be choice A over here. Maybe I should use a smaller font. Second question, it's a compare question. I do not like those, but I think most students do, because they usually begin like this really long, wordy thing, and then they just are asking, oh, which is bigger, which is smaller, or if insufficient information. Don't opt for insufficient information unless it is something completely unrelated. On the test, this is what happens. So you'll be given this thing, and then, for example, let's say this wasn't Y, this was like C. This is insufficient information. They make it really obvious. Sometimes they don't, but most of the time they do. So be careful from that. Don't choose insufficient information. Oh, sorry about that. Don't use insufficient information unless you're really sure that they didn't provide information. Other than that, you should begin by solving or simplifying. In math, always just try to begin anything by just simplifying it. So let's try and simplify over here. You have half root 48 is equals to 2x, which is equals to root 3 multiplied by y.
So how do we go on by simplifying this really messy, wordy thing? Well, let's take it apart. So let's start, let's start over here, okay? Half of root 48. So 48, half of root 48. Again, remember this rule that we used over here. So this is another square root rule that looks similar. 48, what are two numbers multiplied by each other? So two numbers multiplied by each other gives us 48. Now that's the way you find any square root, but since there are no two numbers that are the same that give you 48, you are allowed to use any two numbers that give you 48, but one of them has to be a square root. So let me explain. So two numbers that give you 48, which one of them can give you a square root is 16 and 3. 16 by 3 equal 48. That's just like the exam expects you to just know this, and if you don't, it would be helpful to memorize the multiplication table up until a certain point, but after that it's just luck, I guess, or just logicizing. But so these are two numbers, and 16 can be divisible by like 4. So 4 by 4 give you 16. So they call this a perfect square because it is square rootable. So it's able to be square rooted. Thus, we have, from all of this mess, that 48 is equals to 16 multiplied by 3. So how can we Simplify this even more. We still have the half square root, and it's being multiplied by the square root of 16 multiplied by the square root of 3. So let's simplify this even more. Half multiplied by the square root of 16 is 4 multiplied by the square root of 3. So this is our first simplified section. Just any question that just seems too much or just seems too huge or too large or whatever, just simplify it, and you'll find something. And so I don't know, this doesn't, oh yeah, okay, yeah, this, right, which used to be this part, could now be added to the rest of it. So let's see what we're gonna have. So let's take this, put it over here. As in the question, it says it's equals to 2x, which is equals to root 3 multiplied by y, right? And what we're trying to do in order to compare y and x, we're trying to find, like, in order to find which one is bigger and which one is smaller, I guess, what we're trying to do is find what x is and what y is, obviously, right? So then let's just solve for x and solve for y. Well, to simplify this even more, by the way, half of 4 is just 1 over 2 multiplied by a number is just half of that number. Half of 4 is just 2. So 2 multiplied by root 3 is equals to 2x, which is equals to root 3 multiplied by y. Well, another way of also simplifying equations is by putting them in easier places. So if you will take this whole part and putting it over here, took an extra part with us, if I can, all right, I'll just delete it. If you can just arrange it in a simpler form, and that simpler form will just help you understand what is going on better. So 2x is equals to 2 by root 3, which is equals to root 3 multiplied by y. So over here, to find x, just divide those two sides by 2. You'll find that x is equals to root 3. And you can see here that y is being multiplied by root 3. Well, what else in the equation is being multiplied by root 3? It's 2. And so you can see that y is equals to 2. I hope that makes sense. But so x is equals to root 3, and if you want to compare any two numbers, they have to be in the same form. So you can't say y is equals to 2. You have to say something weird, like, in order to just understand, really, y is equals to root 4. And root 4 is bigger than root 3, and thus value of b is actually bigger. If this still doesn't make much sense, just know that really all what I said is simplify the whole thing. Just simplify the equation, find the missing variables, and compare them. That is the order of things that you have to do whenever you see this. In math, you just need to know to have a structure. You have to know the first thing, where to start, and when to stop, right? Those are the two things you just need to literally solve anything. So you know, in any math problem as well, where to start is just by simplifying it, making it easier to the eye, making it better. And then when to stop just depends on the problem. So that is the solution for question 2. All right, now we have question number 3, which asks if 2 to the power of y multiplied by 5 to the power of y gives us 100, and 2 to the power of x multiplied by 5 to the power of negative x, actually should be negative, equals to 2.5, then what is x plus y? Okay, well then let's start by taking it apart. Okay, so let's start by doing this one first, just taking this equation, finding y, and then doing the same on the other side. So 2 to the power of y multiplied by 5 to the power of y gives us 100. Well, okay, so we have this thing. We know that this like those two exponents are the same number, are the same number for both numbers, meaning that if y is equals to 3, then this is going to be 3 and this is going to be 3 as well. So this helps us because now all that we really need to do is we can literally just try it, because it seems like it's not going to be a really far number to give us 100. If this was like thousands, then maybe we can't just try it. That will take too much time. But since it is just 100, we can do that. We have the time to just test exponents. So we can say, all right, what's 2 to the power of 2 multiplied by 5 to the power of 2? And 2 to the power of 2 is 4, and 5 to the power of 2 is 25. What is that? That's 100. Just like that. So we had the time to do this, and so we found this exponent. If it wasn't 2, let's say if it wasn't 2, we could keep trying. All right, then what's 2 to the power of 3? And what's 5 to the power of 3? We can try up to like 4, right? These are like the common ones, and then after that becomes difficult. And if it doesn't work, then we're gonna have to do another thing to like find what the exponent is. But since it worked, 2 to the power of 2 and 5 to the power of 2 gives us 100, then we know that y is equals to 2 now. We have this, right? Because 2 to the power of 2 multiplied by 5 to the power of 2 is equals to 100. Right, so we can take this out of the way now. And let's see. I'd like to draw a better y. And then let's see. Okay, so we have 2 to the power of x. We're talking about this one now. Multiplied by 5 to the power of negative x. And that will give us 2.5. So first thing I want you guys to do. So you see the decimal point here. It's a bit harder to deal with things when they are in decimal form. So my advice is to study turning decimals into fractions. Why? Because it will prove to be very, very helpful. If you're able to turn any decimal into a fraction, then your life will just become a lot easier, because dealing with decimals is a lot more awkward. So let's say 2.5, the fraction version of it would just be 5 over 2. And so we can just, now we have this beautiful fraction. And and I hope that you guys can see how we're gonna turn this in relation with this, because this is a multiplication and we have a negative exponent, and you know how that works, because I'll explain, but we're gonna just have to relate those two together in order to make this look more like this. So 2 to the power of x multiplied by 5 to the power of negative x. I hope you guys know that in questions like these, I hope that you guys know that taking any number to the power of a negative number, you can get rid of this negative right here by simply putting it over 1. If I do that, then this becomes not negative. So by the way, we're splitting between, so we're focusing here, right? So this is for any negative number. If any number is being raised to a negative number, you can get rid of this negativity by just putting 1 over it. And that's what we're going to do here. So what we're going to do here is make this, all right, let's get rid of this for a second, is make this into not a negative number. So, and by the way, this is equivalent to 1 over 5 to the power of x. Like, we're not changing the equation by putting a number above it. It's the same thing. It's literally this is equals to this. It's like the same concept. So we can take this now and put its fraction adversary instead of it. Adversary means like a friend or something, like working with. So now we have 2 to the power of x multiplied by 1 over 5 to the power of x is equals to 5 over 2, but let's just ignore that for now, or maybe I'll just put it here. Is equals to 5 over 2. So what can we do from here? Well, we know that any number, for example 3 or 4 or 5, if it's just a number, it's always being divided by 1 because it's the same thing. So we can say that 2 to the power of x over 1 is being multiplied by 1 over 5 over x, which if you're multiplying fractions, you can go straight across. And then you'll end up with 2 to the power of x divided by 5 to the power of x is equals to 5 over 2. I hope you see how we came here, and if you don't, please repeat this section. We came here by just turning the negative 5 to the power of x into 1 over 5 to the power of x, and just putting 1 over 2 to the under 2 to the power of x, and then just multiplying across. And there we have this. It's the same. This is literally the same as this. It's just written in a better way in order to further explain things. And 2.5 is the same as 5 over 2. This whole equation is the same. But this is way easier to digest. This is way easier to understand. And so from here we can understand what the exponent is. So we can take this over here. So now let's think about it. And by the way, if we remove both of these exponents and we just put them to the power of x, it's the same concept. It's literally the same thing. If you have the same exponents, for example, if both of them are raised by 2, if you put 2 over here, it's the same thing. But again, it's just making things easier in order to better understand them and make more sense of the whole thing. So we have 2 over 5 to the power of x is equals to 5 over 2. Well, if you guys remember, I just told you that raising any number to a negative number, to negative, n, you just have to put 1 over it. If you do that, then you get rid of the negative side. So it's the same thing for fractions. So if you have 2 over 3, but the 2 is being raised to the power of negative n, what you do to get rid of this fraction right here, you actually flip the fraction. Instead of putting it over 1, you just put it over, you just flip it over its denominator. So it's 3 over 2 to the power of n. That is the same thing. It works. You are not violating the rules of math if you do this. And so here you go. This is to make 2 over 5 flip, you just need to raise it to the power of negative 1. How? So if we have 2 over 5, all right, and I want it to become 5 over 2, I cannot raise it to the power of negative 2 because then I have to multiply both of these by 2. But if I raise it to the power of negative 1, I have to multiply both of those by 1, which is the same number. So you will just flip them, and this of course is 2 over 1, but it's 2 to the power of 1, but it's the same thing as just saying 2. So there you have it. I gave a really, really long explanation, but just to explain what is going on here. The steps for this are really easy. It's just, let me take, I don't want to take the whole thing. Let me take only this thing. The steps for this are really easy. Again, the first step, turning this into a fraction. All right. And then the second step was turning 5 to the power of negative x to 1 over 5 to the power of x. All right. And then the third step was simply multiplying them, which we got this afterwards, and then just recognizing, we want to raise it to a negative number in order to flip the denominator and the numerator, and then we can have 5 over 2, which means, by the way, so please, if something is taking a long time from you, don't be fooled by this. We are looking for x, right? And we found that x is equals to negative 1. And remember what the question was asking. Do not get tricked by this. This is actually a very common trick they will trick you into feeling like, oh, then, you know, the answer is D, -1, because you worked so hard to get X. But this is wrong. The answer is not -1, because that's not what we're looking for. We are looking for what is X plus 2. I mean X plus Y. So it's 2 plus -1, which will give us 1. And that is your answer. So moving on to question 4. We have here this figure, which is a square, by the way. Like the whole thing is a square, like this entire thing, right? It's a square, everyone can tell that. But now let's see where to start. So let's start by laying out what we know. We know that squares have right angles on all their corners, because these equal to 90. And all of them, like each single one of them, is 90 degrees, right? And multiplied by 4, that is 360, which is a rule for squares. So there we go. We're just writing down what we know. We're just getting through it. And then we have that this is 20. All right. And we have that these two sides are equals to each other. They're equals and they have the same angle. If you know a little bit about like triangle congruency, you will know what to do from here. Since these two triangles share an angle, and they also share a side, you can already know that they have the same angles all inside. They're the same triangle. They're literally the same triangle. So this is triangle congruency. Learn about it. Very important. Triangle congruency, they gave me a huge shortcut now. So these two triangles are the same. This triangle and then you have this triangle. They're the same, which means that they have the same angles everywhere. So if this is 20, right? Now since we know that this is 20, we also know that triangle angles add up. They all add up to give 180 degrees, right? That is just something we know as well. So we should know that moving on from here is 20 degrees multiplied by 90 degrees. Added by 90 degrees plus 90. This is equals to 110. Take that from 180. You will be left with 70. And so we know that this angle is 70. And since these are the same triangles, then just move it. So take this triangle and flip it to match this one. So you know that the 90 degree angle is here, and it's flipped over to be here, and this side is this side. So this is the top angle, which is here. And so X is 70. That is, so what did I do here? I solved it in 3 steps. Number 1, I recognized the square. I recogged in order to have sure, like, I'm just gonna have to say that I recognized square, all right? I knew what the square was. I knew its angle theorem. Number 2, I recognized congruent triangles, I believe. Congruent triangles, right? And number 3, there's actually more to it. Yeah, number 3 is that I knew the angle theorem of a triangle. So angles of triangle, right? Like this is really it. This is all I had to do in order to figure it out. and that is all that you have to do in order to figure it out. You could do more, and you should probably do it a little bit faster, right? You shouldn't like take your time putting everything together, but if you have time, go ahead. If you have time, go ahead. The test is mainly trying to see the skills you have and how you just bring them together to solve weird problems. I said this before, I'm saying it again. It is about your skills and not just knowing them, and how to incorporate them. Very good word, incorporate them. I hope I'm spelling it right. Incorporate them. It's about your skills, how you incorporate them, which just means bring them together, right? Just means bring them together in order to solve anything. So in here we just used general knowledge about geometry. What a square is, the angle theorem. So the insides, like knowing that the insides of a square, like the angles inside give you 90 degrees. We use the congruent triangle theorem. We use the triangle angle theorem, which these are just fancy names for defining random things in math. You don't really need to know the name, you just need to know what happens, right? Which is something that schools focus on, which is not very nice, that they just tell you the name and then you forget what the thing is. So just try to know that. In here I skipped 5, 6, and 7. These questions are obsolete. They are no longer on the Qudurat test. You will not get free questions like that on the Qudurat test. So let's just skip them. Let's just pretend they're not there. They are. They have a graph. They're free questions. It's just like, oh, this minus this is equals what? Oh, what's the biggest? What's the smallest? They're dumb questions. They're not gonna come on the exam. Don't treat them as important because they will not come. Now we fall on to question 8, right? So moving on to question 8, you have the root of 72 over the root of 3 divided by the root of, 27 divided by the root of 3, yada yada yada. Okay, well this thing looks insane, right? Roots and fractions, and it's all messy. Let's begin by simplifying it. See, every question, you have to know where to start, how to simplify. You are not ready for the exam unless you just have a puzzling mind that, unpuzzling mind that just knows how to simplify things and make them easier to digest. It's like food. You chew food in order to digest it. So here, let's chew this equation in order to digest it. So first of all, two roots being divided by each other is just the same as this, right? 27 over 3. It's literally the same thing, right? I hope it makes sense. It's just the same thing. 72 over 2. They are equal. This goes back to the roots rule, where like it's the same thing except with division. Last time we did it with multiplication. It's the same thing this time. It's just that this is division, right? So let's see what we can do here. All right, let's ignore the square root for a second. What's 27 divided by 3? Well, we know that that's 9. So we have 9 divided by, what's 72 divided by 2? Well, if you don't know, you can always use long division, all right? Long division. How many 2's fit into 7? Well, not 4. They're going to be 3 because it will give us 6, all right? Just take down 1, bring down this 2. How many 2's fit into 12? 6 2's. And so it's 36. Or you can just do it in your head way faster, but here's how it is, right? Long division is very helpful, but so we have root 36, which is tiny now. We have the square root of 36. And so we can figure it out. Root 9 is 3. That is a famous square root. Two numbers multiplied by each other, giving us 9. And root 36 is 6. It's a famous square root. Two numbers multiplied by each other, they are the same, that give us 36 are 6. So this is how you figure it out. And now you have something way easier to digest. Look at that. It's just 3 divided by 6. This whole mess is the same as this. It's literally the same thing. And so you can put them as a fraction, right? 3 over 6. And that is the same as 1 over 2. It's a simplification, really. Again, like 3 over 6. 3 is half of 6, so it's 1 over 2, right? And that is answer A. All right, let's move on to question number 9. So 3, 7, 2x. All right, let me read the question. If 3, 7, 2x are 3 values such that 3 is bigger than 2x, it's bigger than 7, which is bigger than 7, and the median of these values is 4, then x is what? Okay. Now, this is the trick in it, actually. They just expect you to look at this, right? 3 bigger than 2x, which is bigger than 7. That means that 3 is bigger than 7. How is that, right? It's a big question mark. Well, you shouldn't really be concerned with that. You shouldn't really care, because imaginary numbers exist. Imaginary numbers are numbers that are not real. They are, as it is said, they're imaginary. So this is completely fine. If the question is telling you so, it is what it is, right? So 3 is bigger than 2x and it's bigger than 7, right? And they told us that the median is 4. And we know that the median is the middle number. So if you have x, x, and x, this is the median. It's just the middle number. So they told us that the middle number is 4. And we have 2x over here. So they told us that 2x is equals to 4. So if you divide both sides by 2, you will find that x is equals to 2. And that's literally it. That is the answer. X is equals to 2. Right. Now moving to our last question of today. If 3 times a number is 6, then quarter the number. Okay, wait, hold on. There's a mess over here. Then quarter of the number is, well, there should be a the over here, but let's not concern ourselves. The quarter of the number is what? Okay, so 3 times a number, 3x is equals to 6. Divide both sides by 3, you'll get that x is equals to 2. Makes sense so far, right? As I'm just using what they told me, okay? And then so quarter of that number, so here's that number, right? So they want the quarter of it. The quarter of it is just 1 over 4. 1 over 4 of 2. Well, what 4 things, right? X plus x plus x plus x, like give us 2. What 4 things could those be? Well, 4 halves, because 1 over 2 plus 1 over 2 is 1. And the same thing goes to give you another one, and then you end up with 2. So quarter of that number is half. This question is not complicated, but they try to complicate you. They literally could have just replaced this 3 by just putting a normal 3, and you would see times and you'll be like, oh, that is x. A number is 6, right? So 3 times a number is 6. So that number is x multiplied by 6. Like, it's just that they're playing games on you, and you have to catch on that early. So when you see something that is full of words and you don't really understand what those words mean, just try to think of it mathematically. What are they trying to ask for? 3 times a number. 3 times x, a number, x, n, fucking like m, right? Anything. So 3 times something is 6. Well, 3 times what is 6? 3 times 2, and so on and so on. And they could have easily replaced quarter with 1 over 4, but they are trying to see how intelligent you are to figure that on your own by simplifying word problems. Those were our 10 questions of the day. I hope they were helpful.